Okay. So welcome everyone. This is Tuesday, September the 19th, and it is the live Skype session for Chemistry 1046, and we're looking at the intro unit. So great turnout tonight, and there's more people coming in, which is great. Erica is here. Erica, if you can hear me, let me know. This is great. So the idea tonight is that if many of you may have already worked on the worksheet that I gave out in the announcements, if you missed that, just go back into D2L under the news feed and you can scroll and see where I attach that. So I'm going to take questions about that worksheet. That's what I did is I looked at what you needed to be able to do on the test, and then I just created a worksheet so that you could get some practice around those things. So if you have worked on it and you have questions, we'll be going over that tonight. If you haven't had the chance to work on it, but you want to take this time now to start working on it, that's fabulous. That's what this is for. And then you can come back into session when you have a question and ask me any questions you like about that. And this worksheet is not to pass in. The answers are provided. There's an answer key for both Chapter 1 and Chapter 3, so you'll know right away whether you have the answer or not. If after this session you have any questions about this, just post in the Unit 1 just post in the Q&A discussion the questions about the course, which is in the Welcome unit in Chem 1046. And I can answer them there, or you can email me directly and I can answer that way as well. But I also want to take time tonight to answer any of your general questions. So maybe I will do that first. Let me just bring up my whiteboard. There we go. And I'm just going to grab a pen and check. Yep, we're all working fine. Okay, so does anyone have any questions, not regarding the worksheet at this time, but maybe just something general about maybe the separating mixtures lab that's due on Friday? You also have a discussion, post and reply to do by Friday, and of course the intro assignment, which is that quiz that you can get into and out of, that's due Friday as well. If you have a question, feel free to grab your microphone if you'd like to ask that way, or you can type in the chat window. And if you don't have any questions regarding, like generally, but they all have to do with the worksheet, maybe you can just let me know in the chat window that you're okay for now. You can give me the thumbs up or a smiley face to say that you don't have any general questions at this moment. But if you do have a question, grab the microphone or type in the chat window. Tracy's good. She's giving me the thumbs up. So far, so good. Feel free, if you think of something later on in the session, you can ask me then. And those of you that aren't here tonight and that are watching from home, feel free to email me your questions as well after you watch this. Great. Erica's good. Nancy's good. Tracy said she lied and she has a question. No problem. Tracy, go ahead about APA formatting. So we're going to wait for Tracy to do that. Well, if you are going to reference something for the form for the separated mixtures lab. So if you reference something, you are using something in the textbook that you would like to recognize, then I'm not looking for in-text referencing. Just at the very end of your lab, you can put a reference page and then list the book in APA formatting. Title page, no, title page is not needed. Just a title for your lab, and that's all. So for this separated mixtures lab, at Yeah, at most, I think that most people will probably just write down that they use the text. I'm not looking for people to go out and do a whole bunch of research on this. Just citing your text as your main reference material is great, and you don't have to do any citing of page numbers um, within your lab write-up. So very, very simple terms in terms of APA formatting. That was a good question. Thank you, Tracy, for bringing that up. That's great. Any other questions since we are on the topic of separating mixtures lab? I hope everyone saw that in the references, if you go into D2L under content, the very last tab after all the units is a resources and videos, and there was an example template for a lab write-up, how to format it, and then there was also an example of how a lab is written up in with a real world example. So if you follow those two resources, so your lab report looks like and sounds like those, you'll do great on this lab. I'm checking to make sure that you have all of your title, all of your headings, like your purpose, your hypothesis, materials, that sort of stuff. And then I'll be checking to make sure that you've included what you should have in those sections. Okay, if everybody's okay with that, that's great. I'm going to open the floor then up to the worksheet questions and also to any other questions you might have had in this unit. Who's going to be brave and go first? I bet that there's going to be questions about the specific heat formula one. So if you want to just shout out a question number, I've got the worksheet in front of me and I'm happy to work out any question that you might have on those. Anyone lost about what worksheet I'm talking about? Give me a thumbs up if you're fine, if you're okay, if you know what worksheet I'm talking about. How about that? Or a smiley face or something fun, something positive. Great. Awesome. Okay. How many are working on it right now and they're going to use this session to work on it and then have me to answer questions while you're working on it? Nancy, is that a high five or a raise your hand? Great, Tracy. That's awesome. Good. I like it, Nancy. It's a high-tech high five. That's awesome. I love the emoticons. I miss the old system that we had just because there was an opportunity to actually raise your hand. But Skype has been working pretty well for us, so we've been okay so far. Okay. Well, if there aren't any questions at the moment, those of you that are working on the worksheet, just tune us out and go ahead. You'll notice that at the end of the chapter 1 questions, the answers are there for you, so you can check your answers. And then at the end of the chapter 3 questions, the answers are there as well. I was thinking, does anybody have any questions at this time regarding chapter 1? Maybe we can take it one chapter at a time. If you look over your worksheet at this time, those of you that have finished the worksheet, are there any chapter 1 questions? You can grab the microphone or you can use the chat window. Have a little look through that. Maybe look at the answers and see if anything was perplexing. So far, so good, perhaps. I'm going to give you another minute just to take a look at that, and then if there aren't any questions at this time, then we'll move on to chapter 3 and see if there's anything we can do there. And we can always go back and revisit for those of you that are still working through the worksheet. No problem. The nice thing about this unit is that there isn't a test, so you can go into that unit assessment and have a look at the questions, and then you can pop back out. There's no time limit on that, and you can go in and out as you please. Some students have found that when they pop back out, their notifications were blocked. And I thought that I had changed the settings. I think, Nancy, you're one of the ones that I was having that's having trouble with it. I have the tech people are right now working on it, so I'm hoping that they've been in contact with me, and I'm hoping by tomorrow morning they get that figured out. Nancy, did you see any changes on your side?
No, mine is still blocked. Someone tried to page me and it didn't come through. I couldn't click on it.
I think the page might have been from me. It might have been either about Skype the other night or just a hey, how are ya? So I
didn't get it.
Not yet. So it's not, if that's the one that was from me, it wasn't anything that you had to act on. But as soon as the tech can turn that, whatever that setting was, off, you'll be able to access it. And I'm hoping, I last talked with them at 4:30, and they said they were on it. So my fingers are crossed.
Sounds good.
Okay, good. Okay, if everybody is fine at this moment with chapter 1, chapter 3 has a bit of math in it, especially question numbers. The short answer ones, the 1 to 10 at the end. Are there any questions there that you would like me to go over on the whiteboard? Have a look and see.
I have a question. Can you hear me?
I can. Who is this?
It's Tracy.
Oh, hi, Tracy. Go ahead.
Hi. I'm just it's too long for me to type it, so I'm just gonna ask
for
it.
sure.
I don't have I missed something? Are we not doing, is there not a study sheet for chapter 2?
Chapter 2 is not covered in the assessment quiz, and it was just there as sort of a math refresher. So if you wanted to do a little bit on, just to refresh from the last math you had, you could do that, but we're not testing you on it.
Perfect. Okay, yeah, I thought I was just wondering about that. It's probably best that I do review it, but I was just wondering.
Just take a glance at it, and if something comes up, you're like, oh, I think I should maybe just have a quick, like a little bit of a look at that and polish up, go ahead, but it's not going to be on that intro assignment. Yay!
Yay.
Yeah.
Okay, thank you.
You're welcome. And I see Stephanie and Michelle have joined us. That's great. Hi, guys. Welcome tonight. Hi, Stephanie. So I'll give you guys a few moments, and then if nobody has a place to start, I'll pick something in those. I think that the math questions are probably the ones that are giving people the most headache, but feel free to ask me any of the other true and false ones if you like. And I see Brady is typing, so I'm going to let him finish. No rush at all. And just while people are typing, I see Brady and Stephanie. Oh, there we go. There he is. Oh, Brady, that's a great question, and you're not changing the subject. This is great. So Brady wants to know if the tests are cumulative or are they broken up into separate units or chapters, if you know what I mean. So Brady, every unit except for unit 1 has a test, and it's only going to be on the chapters for that unit. So you won't have to do questions from the previous unit. It's going to be broken up into separate units. So there's going to be a test for each of the units. Now this unit, the very first unit, is just the quiz, which is called the intro assignment. And if you haven't watched my first Skype session from last week, I recommend that you do, because I was showing the difference between a quiz and a test because they look the same in D2L. So if you haven't watched that, go into the news feed after this, or when you get a chance, and just watch that live Skype, because I go over the difference, what it looks like in D2L. So Unit 1, which is the unit we're in right now, just has the quiz, and you can go in and out as you like. But the tests themselves, starting in Unit 2, there's going to be 1 per unit, and there isn't a final exam. So just the unit tests. So you don't have to worry about a final exam, but you must score 60% on each test in order to pass the course. So there are 2 requirements in order to be successful in the course. One is to have an overall grade of 60% or above, and the other requirement is that you get 60% on each individual test. And what that means is that you could have a scenario where you have an overall passing grade, but you fail 1 test. Technically, that would mean that you would not be successful at getting the credit. So it's super important that if you do fail a test, you let me know, because I do have options to try and make that up, depending on how you're doing in the course, what your struggles were on the test, and how you've been doing. So don't worry too much if you fail a test and it's the first test that you fail, because there are options to make that up. The only way that there wouldn't be an option to make up a test is if a student were consistently failing every single test, because that would be indicative that it's just the wrong timing to do the online course. That was a long answer to your question, Brady. There is a time limit on the test, and I believe it's 2 hours. I'm going to double check that, but if you go into the test, just don't start them. They do give the how long each of the tests is in the little intro section, but usually they're 120 minutes. You're welcome. And some of them are proctored, so you want to check out your schedule for that. And for proctored tests, you will have to make an appointment with a campus proctoring center. And I will be posting a link to that proctoring center appointment information next week when once we get Unit 1 done. You're welcome. Thanks for the question. And I think I missed one up here. Stephanie. Oh, let me go. Oh, Stephanie, no problem. Yeah. Bedtimes are busy, I know. And the recording, I've already started the recording, so you'll have that. Oh, to state your opinion. Example, my salt ended up not being what I had expected. Can I state what I believe happened? Ooh, I like that. So a couple of things. You can explain your results as to what you think happened. In terms of your example there, my salt ended up not being what I expected. That's a a good statement, except for the fact that you're using personal pronouns. So in a lab report, personal pronouns like I, me, my, we try and keep those out. So how I would rewrite that, and this is something that you would talk about in your discussion, not in your data, but in the discussion section, the very last section. You can see the final amount of salt measured was not expected. It is believed that that the salt perhaps bounced out of the pot when it was heated, because it could be seen that the salt had popped or something like that. So just no problem to give your own explanation as long as it's scientific based. So and that is, you saw that the salt was popping out of the pot if you used a pot, and therefore you feel that that affected your final results. Just try and state it without the personal pronouns. Does that make sense? And put that in the discussion, not in the data results, because the discussion is where we talk about what happened, whereas the data is just what was measured and what was observed. Great, Stephanie, I'm glad I could answer that for you. And for everyone, if you have questions like Stephanie had as you're going through this week, and you're writing up, you can text me on my cell phone, 902-403-1394, and that contact info is in the outline on the welcome unit. Just give me a quick text, and because I know as people are writing, they might come up with questions, and if you do that between 9 and 10, I will text you right back, as long as I'm not driving or in a phone meeting. But there's that option too, and you can also email me as well. And Erica, question is, are the tests multiple choice? And the tests are all multiple choice, Erica. Yes, they are. They're all in D2L, so it's going to be a multiple choice question. There are math questions, so you will be given a piece of scrap paper to work out your questions, and then you're going to choose the answer that fits as closely as can be with yours. So you might find that an answer is close but not exactly yours. In that situation, just pick the one that's closest to yours if it's not exactly what it is. Okay, and I will say, just as an add-on to that, after you write a test in chemistry, you can go over it and see what answers you got wrong. If you feel that the computer, because it's the computer that marks it immediately, so you'll know right away what your mark is, I would encourage everyone to write down the questions that they got wrong, and then check the answer that you got on your scrap paper, and then you can send me off an email that says, "Hi Lori, I got these questions wrong. I'm not sure, like in question 8, I had this answer. I'm not sure where I went wrong. Can you help me?" And that's a great way just to reflect on your learning, and I can help you with that. So don't ever feel that it's all up to the computer. In terms of marking your tests, you just have to bring me into the loop, and I'm happy to take a look at your tests. So that's completely, I encourage that for sure, especially when it's multiple choice, because sometimes you might have an answer that that the computer says is wrong, but if it's reasonable to me, I can override the computer. Okay, I'm going to look back up the list. Erica, did that answer your question okay? You can give me a thumbs up if you like. And folks, if you don't feel you have to stay for the whole evening, if I have answered your question and you don't have any more and you need to go, feel free. Great, Erica. I'm glad we got that covered. Okay. Any other questions? They can be of a general nature or they can be about the worksheet. You can throw out a worksheet number if you like, or a question from the textbook or from the lab, whatever you like. Oh, Ashley, thank you for that. So what it looks like is that you were finding out how many joules are in a 225 cal candy bar, and the answer is 9.41, but I kept getting 941,400. It looks like you calculated little calories instead of the big calories. So that's and that's a great question to bring up, because there is a difference between calorie written with a big C and calorie written with a little c. And the calorie written with the little c is the smaller calorie, whereas the calorie written with the big C is actually 1,000 little calories. So it's a kilocalorie. And this calorie with the big C is how we measure calories nutritionally. So when you are reading your breakfast bar or a chocolate bar or the nutritional value, how many calories are in a food item, the calorie that's mentioned there is actually 1,000. Each calorie mentioned there is 1,000 of these little calories. So the 941,400, you measured little calories, but in order to convert it, so 941,400 little calories with little c, if you divide that by 1,000, oh, we're still not quite there, because it's 1, 2, 3, 4, 5. You have divided it by 10,000. Do you have the page number that's on, Ashley? And I can do the question here to see why you're off. It's just your decimals off by a little bit. Page 74? Perfect. Excellent. Let's bring that up and see what's going on. There we go. Okay, I'm just going to clear this up. Select all. There we go. Sure. So let's look at that question. So the question is, as you said, you have a candy bar that contains 225 of the big calories of nutritional energy. How many joules does it contain? So we're looking for joules, and so we need to do a conversion. So first of all, we have to look at our conversion factors, and if you look on page 73, we see that 1 little calorie is equal to 4.184 joules. And if we had little calories, then we could just do a straight conversion. But we don't have little calories, we have the big calories. So what we need to do first is convert our big calories to the little calories. This is a little c. And then we're going to convert the little calories to joules. Ashley, does that make sense so far? So big calories to little calories, and then little calories to joules, because we don't know how many big calories there are in joules. Great. So what I'm going to do is I'm going to do this part first. I'm going to switch big calories to little calories. And when I do that conversion, I'm going to do what's called a dimensional analysis. I'm going to use conversion factor to help me out. And the conversion factor I'm going to use is that 1 big calorie is equal to 1,000 little calories. So that's going to be my conversion factor, and I'm going to put it into a fraction. But I always start out with what I'm given, and I was given 225 big calories And I like to call them big calories because that helps me to keep it correct in my head. So 225 big calories that I want to convert to little calories. So this is my unknown that I'm trying to find out. And when I'm doing dimensional analysis, I'm going to use a conversion factor in the form of a fraction. And the conversion factor I'm going to use is that 1 big calorie is equal to 1,000 little calories. Now the question is, where do I put my units? Where do I put my big calories? Do I put it at the top of the fraction, up here in the numerator position, or do I put my big calorie units at the bottom? And the answer to that is that I want to cancel out my big calories so that I'm left with my small calorie units in my answer. And whenever you are canceling out a unit, you want to cancel it out by putting that unit on the bottom of the fraction in the denominator position. So I'm going to put big calories on the bottom, and that way when I divide by calories, I'm actually canceling out those units. So whatever you're trying to cancel out so that it's not going to be in the answer, put that as the unit on the bottom of your conversion factor. So now that I know that I'm putting big calories on the bottom, I'm going to put 1,000 calories, little calories, as my numerator, and 1 big calorie as my denominator. And that is my conversion factor. Right there. My big calories cancel out, as I said, and that's going to leave the little calorie in my answer. And then I can just do the math. Ashley, so far, are you okay in the way that I set this up using the conversion factors and why putting the big calories in the denominator position is so important to canceling out? Any questions about that before I do the math on actually figuring out how many little calories I have? And if anyone else has a question that they'd like to interject, go for it. Great. So once we have the unit set up, now we're going to do the math. So what I have, I'm going to grab my arrow here. There we go. I have 225 times 1,000 divided by 1. So I'm going to just do this in stages. I'm going to take 225 and I'm going to multiply it by 1,000. And you can do it in your head or you can do it on a calculator. Calculators are allowed on your quizzes and on your tests. And 225 times 1,000 is 225,000. And then I'm going to divide by 1, and that doesn't change my answer. So if you were to put that into your calculator, you would go 225 multiplied by 1,000, hit the equal sign, get your answer, and then divide by 1, which doesn't change your answer, but for some it's great to have to know that it didn't change and just to test that out. And what I get is that 225 big calories converts into 225,000 little calories. So that's part 1 of my solution. Ashley, is that okay in terms of how I did the math for that? Great. So I've gotten the first part of my solution. I converted my big calories to little calories, and now what I want to do is got a red one. I want to take my little calories now, and I want to convert them to joules. And I'm going to use the same dimensional analysis that I did to switch big calories to little calories, but now I'm going to use the conversion factor of 1 calorie is equal to 4.184 joules. So when I set that up, I start with what I'm given, or what I figured out, which is my little calories. So I'm going to go 225,000 little calories, and I want to figure out how many joules that is. So that's my unknown. and then I'm going to use my conversion factor, which is 1 calorie is equal to 4.184 joules, and I'm going to put that as a fraction. So I have to decide, am I going to put calories on the top and joules on the bottom, or joules on the top and calories on the bottom? Because conversion factors, you can do that. You can switch around what's on top and what's on the bottom, but it all depends on what you are canceling out. So what should I put on the bottom here? Should it be joules or should it be little calories? What do you guys think? Feel free to answer in the window. So Nancy's saying joules, Stephanie's saying calories. This is going to be on the bottom one, and remember, we're trying to cancel out calories, little calories, and whatever is on the bottom is going to be what's going to cancel out the calories, the little calories. And that's right, yeah, so we're going to put little calories on the bottom because that's going to cancel that out, which means we're going to put joules on the top, and the joules aren't canceled out, and that's what's going to be in our answer. So with that, I can then put in what the conversion factor is, and the conversion factor is 4.184 joules over 1 little calorie. So my calories are now canceled out. I've got joules in my answer, and now I'm going to do the math. So this one I'm going to need my calculator for this one. So I'm going to turn it on here. I'm going to grab my arrow here, start with my first number, 225,000. I'm going to multiply it by 4.184. Oh, might help if I multiply. 225,000 multiplied by 4.184, and I get an answer which is 941,400, and then I can divide by 1 right here, which doesn't change my answer. And so how many joules I have is 941,400 joules. And that was the answer, Ashley. I think, now looking at your question, I think what happened is that you skipped a step. You went right from going from calories right to joules, instead of realizing that you were dealing with big calories and that you had to go from big calories first to little calories and then little calories to joules. You just skipped a step, that's all. Oh, but it says the answer is 9.14. Oh, yes, it does. It says that it's 9.41 times 10 to the power of 5 joules. So what they have done is they've put it in scientific notation. And what the 10 to the power of 5 means is that you want to move your decimal place over 5 spaces, or 5 decimal places. So if the decimal was here, and you move it over 5, 1, 2, 3, 4, 5, it's the same answer. So this is called scientific notation, and we use that when we want to express an answer in a specific number of decimals. And in this case, they're doing it with significant figures. So you might be saying, well, why did they write it in significant figures? Well, the information they gave us, the 225, has 3 significant digits, and so our answer should also be in 3 significant digits. And because it wasn't, they wrote it as scientific notation. And in Unit 2, there's in Chapter 2, there's a whole section on scientific notation and on significant digits, and I also put up a video on that as well. Ashley, if you, for instance, on your test wrote, couldn't see, got the, because it's multiple choice, so I'm trying to figure out what you would see. You could, and you got the wrong answer, but because you didn't put it into scientific notation, you could always tell me afterwards in an email. But I do recommend that you brush up on scientific notation. Scientific notation in chapter 2, because that's going to help you in unit as we move forward as well. But the good news is you did get the right answer. So that's good. And Nancy's saying that she's doing math right now as well. Yeah, there is a little bit of math in Chem 1, which is 1046 that we're doing now. There's a lot in Chem 1047. So brushing up on what you can now will really help you for Chemistry 1047 for sure. Okay, Ashley, does that sound good for now for that question? I'm glad you brought that one up because it covered a lot of different things in terms of conversions, and that was a multi-step conversion problem too. So it was more complex. So it was a good question. And if you haven't watched my video on significant figures, it's listed in the news feed, and it shows you why we use significant figures, that there is a reason why we use it, and it has to do with when we're analyzing a whole bunch of data when we're doing lab experiments. So if you haven't watched it, it's a good one to watch just to put some background to that. Great. Okay, I am going to give us another page on this, or just bring it down a little bit. Any other questions? I believe in the worksheet that there, number 2 was talking about converting calories and using conversion factors. Number 3 was doing that too. And then number 4 for chapter 3 and 5 and 6 were converting degrees Celsius to Fahrenheit and Kelvins using the formula. Maybe does anybody have any questions on those? Or how about those specific heat capacity questions using the formula? Does anyone want to shout out a question for me to do or have a question based on those? I think number 8's a good one because it's one of those ones where you have to find a final temperature, which can be a little bit tricky. Anybody want to throw something out there in the chat window? How about if I do number 8? Do you guys want to give me a thumbs up if that one sounds good to you? I'm going to bring up the question here. Let's see, chapter 3, number 8. Good, okay, awesome. So this is number 8 in the on that practice worksheet, and it said, what is the final temperature given 25 grams of water? So I always like to write down the data that I'm given. So I'm given 25 grams of water, which is H2O. You could put water. I'm used to using the formula, but water's fine. So I have 25 grams of water, and it was 25.0. I'm going to put that in just so I'm using the exact data from the worksheet. So I have 25 grams of water supplied with 348 joules of heat. So 348 joules of energy, heat energy, will gain a temperature of 5.2 degrees. Oh, sorry. I'm reading from a different question. That's my eyesight for you. What is the final temperature of 25 grams of water at 20? There, sorry. I got the question mixed up. me go back here. So I have 25 grams of water, and at 22 degrees Celsius, so this is my initial temperature. Sorry on that. 22.0 degrees Celsius, that's my initial temperature, after it absorbs 454 joules of heat. There we go. So heat energy. So my question is, what is going to be the final temperature? And I'm going to use my the formula, which is the amount of energy, Q, which will be in joules, is equal to the mass of the sample being measured times its specific heat capacity times the change in temperature. And what you'll notice is that we do have how much energy is put into the system, and that's 454 joules. We have the mass of our sample, which is 25 grams of water. In terms of change in temperature, we have just part of that. We have the initial temperature, because we can rewrite this formula as the amount of energy, mass, times specific heat capacity, times the change in temperature, which is always going to be the final temperature minus the initial temperature. And because I'm trying to find the final temperature, I do have to expand the formula of change in temperature out. Whenever you're finding the change in something, it's always going to be its final amount subtracting its initial amount. And you do have to scroll down if you can't, if it's not, if you can't see what I'm doing. Sorry about that. Thank you, Brady. Okay, so what I'm going to do now is I'm going to put in my data for my variables. So I have the amount of heat energy for Q is 454 joules. So it's really important that you put the data in the right place. So that's in joules. My mass is 25.0 grams times my heat capacity. And you'll notice that I'm missing my heat capacity, but the heat capacities in your book are listed. Where are they listed? They're listed in the book, in the chapter, so you might want to put a little, just a little, you could put a little like piece of tape so that you can go to them quickly. Also, if you look up water in the back of your textbook and specific heat capacity, it will be there as well. But that's something that you would have to look up. But oftentimes, because we use it so much, eventually you probably will memorize it too. Tracy, you're saying it's on page 77? Let's see. 75, 76, 77. Nope, not there. Let's see. Oh, there it is. On page 80. 80, section 3.11, table 3.4, specific heat capacities of some common substances. So they give different metals, and at the very end it says water is 4.184 joules per gram degree Celsius. So just mark that in your book. And then I'm just going to finish this off. I have my T final, which is what I'm looking for, subtracting my T initial, which is 22.0 degrees Celsius. And now it's going to be all about rearranging this formula so that we can solve for T final. Now I just want to make sure that everybody is okay with the numbers that I've put in and where I've put them. Does anybody have any questions on that? The big one that you might have wondered is, where did you find the specific heat capacity for water? And that you have to look up, and for your test it will be one of those in that table 3.4, so it's not going to be something that you have to memorize. You just need to go and look at that table and look it up, and which is what the chemists do. They just Google it, unless it's one that they use often, and this specific heat capacity of water is one that they use often. Okay. Give me a thumbs up or a smiley face if everybody's okay with that, or type a question. Otherwise, I'm going to move on and show how to rearrange this formula algebraically. I have a few students that say that they're rusty on their algebra, so they're having to polish that up a little bit. So if you're rusty on your algebra, pay close attention, because I'm going to show you how to rearrange this formula. Go ahead, Stephanie. You have a quick question? Oh, so we're looking for T final, because that was what the question asked for, is what is the T final? And when you look at this, the original equation, T final isn't part of that equation. You are correct, but it's hidden inside of this change in temperature. So what I did is I expanded out change in temperature, and the formula for change in temperature is T final minus T initial. So I just expanded out what change in temperature is to show T final and T initial, and I do have the initial temperature, and I'm trying to find T final. So that's where that TF minus TI came from, is that it's the change in temperature. So you need to know how to use this formula, but you also need to be able to use this formula here, which is expanding out this change in temperature. I would say that this is one of the more complex problems, because you do have to expand out the change in temperature and then do a lot of rearranging to get the final temperature. So sometimes they might ask you for the final temperature, sometimes they might ask you for the initial temperature, and whenever they're asking you for a final or initial temperature, you're going to have to use this formula here. Okay? Does that answer your question, Stephanie? You're welcome. You can write this down and then go and bring it back to your husband and see, and anyone can go back and bring these back to your tutors and show them this, and they can help you with it as well. What I want to do next is I want to basically isolate the T final so that I can solve for it. And in order to isolate it, what I need to do is bring all of the numbers over to the other side. So I want to bring 25 grams over to the other side, 44.184 over to the other side, the 22 degrees Celsius over to the other side, so that I can solve for T final by itself. So we're using algebra to bring this around. One of the things that I'm going to do before I start moving things around is to simplify anything that I can. And what I see right away is that I can simplify this. I have 25.0 grams times 4.184. So what I'm going to do is I'm going to multiply these two numbers together, and that's going to simplify my equation just a little bit more before I start rearranging them. So whenever I simplify an equation, I just write it down again. I like to have all my equal signs line up, but because I'm writing on a whiteboard, it's not quite working, but that always seems to help to keep everything neat and tidy. And when I multiply using my calculator, 25.0 times 4.184, I get 104.6. And I try not to round anything off. I try and keep my numbers in its fullest form wherever I can. So 25 times 4.184 is equal to 104.6. So now I've simplified that data down to one number, and then I'm just going to keep the rest of my formula as is. Oh, that's a decimal, degrees Celsius. Okay, so I've just multiplied these two together and got 104.6. Now what I want to do is I want to bring 104.6 over to the other side. I'm not going to do the 22.0 degrees Celsius yet because it's still inside the brackets. So that's the last one that I'm going to deal with. Anything in brackets you want to leave till the very last before you bring it over. So to bring this 104.6 over to the other side, I have to do the opposite operation that's happening. So looking at the operation here, I'm multiplying. What's the opposite of multiplying? Anybody can answer that.
Dividing.
Oh, pardon me?
Dividing.
Dividing, that's right. So we're going to divide this whole thing by 104.6. And when we divide 104.6 divided by 104.6, we get 1. That's canceling it out. And whatever we do on one side, we also need to do on the other side. And that's algebra. That's isolating and bringing things over. And whenever you bring something over, you always do the opposite operation that's happening. So we were multiplying over here. So when we divide, we cancel out the 104.6 on the right hand side, and then we also have to divide by 104.6 on the other side. So next thing I'm going to do is I'm going to do this calculation. 454 divided by 104.6 is equal to 4.34. And I'm going to keep a few more of the numbers just so that, because I don't want to round it off too much, I'm just going to put some of the numbers. It's really long, 4.340344168, but I'll just leave it as that. And that's equal to now T final minus 22.0 degrees Celsius. So I'm getting closer to getting T final by itself. I still need to bring this 22 degrees over to the other side. So just like I did in the step before it, I look at the operation that's happening. I'm subtracting 22 degrees Celsius. Yeah, I heard that. So now I'm going to add. I'm going to do the opposite. I'm going to add that. So when I take negative 22 degrees Celsius and add 22 degrees Celsius, that gets rid of it on this side because that's going to give me 0. And whatever I do to one side, I have to do to the other. So if I added 22 degrees on the right side, I'm going to also add it to my left side. So that's going to give me 4.3403 plus 22 degrees. And I'm going to get 26 and some change. 0.34 is equal to my T final. So it looks like I have my answer here, but the last thing I need to do is I need to do my significant digits, which is to express this with the least amount of numbers possible looking at the data. And the data, if I look back up here, I can see that my data are all written with 3 significant figures. So 25.0 is 3, 22.0 is 3, and 454 is 3. So that means I need 3 significant digits as well in my answer. And I always start my significant digit count on the left. So here's my first significant digit, here is my second significant digit, and here is my third one. So I just want to do it to there. Looking at the number directly after it's a 4, that's not going to change. It's less than 5, so that means that my answer is going to be 26.3 degrees Celsius is equal to my T final. And that is the answer to the question. So if this was a multiple choice and you got 26.34 in the multiple choice, you're going to get 26.3. We're not going to try and mess you up by putting 26.34 and another answer that's 26.3. It's going to be just one answer that is the final answer and nothing close to it. So even though you got 26.34, just pick the multiple choice answer that's the closest to it. It'll be written in significant digits, and then you'll get the right answer. If for some reason you say none of the above because you didn't see your answer there and you didn't pick the closest one, you could just let me know that you messed up on the significant digit part of it and that you should have picked this one. So I know in the beginning we're still getting used to doing the multiple choice questions and significant digits, so I understand that, and I expect that there's going to be, you know, some mess ups that way. But that is the answer to the question. And I think that was, let's see, I forget who asked that question. Does anybody have any questions about that? Tracy, do you have a question about this one? Was it about this one or what?
Specifically related to...
Yes, go ahead.
It's more in regards to generally what will we need to memorize in regards to like joules and calories and things like that. Will we have that information available to use for the conversion, or do we need to memorize certain ones?
Well, for this unit, and actually for all the units, all the tests are open book. So you have your book and the conversions are in there. So you shouldn't have to memorize anything.
Okay.
Yeah, and even the proctor test, you're allowed your textbook as well.
I see. Okay, that's a great answer.
Yeah, I like that one, right? Great.
Yeah. Okay, thank you.
You're welcome. Well, we're at the 8:34 mark, but I don't want to leave if people still have questions. Is everybody okay with this one? Give me a thumbs up if you're okay with this. Maybe it's one that you're going to look at a little bit more closely. You've written down and then you're going to figure out a little bit later. But there are more questions like this on the worksheet with answers. But does anybody have any specific questions about this one? Tracy took a screenshot. That's great. Oh, and I think that, is there a place where you can download these? I'm just looking. Sometimes you can download the whiteboard. A screenshot's great. Most computers have a print screen button. Stephanie, you're sending it to OneNote. Can you write down how you're sending it? To OneNote? That's beyond me. I think because I'm in presenter view, I can't see how that's done. Oh, thanks, Stephanie. Erica's saying you just need more practice. There are more practice on that worksheet, Erica, and lots of exercises in the textbook as well. So Stephanie's going to plug in her mic and tell us how she downloads this to OneNote. Oh!
Can you hear me?
Yeah, I can. Thank you, Stephanie.
Okay. Do you see on the right-hand side on the whiteboard, there's the pencils and the eraser and check mark?
Yes.
If you click the three dots,
nice.
It'll say Save As or Send to OneNote.
Perfect. So you're sending it to OneNote, but I have a feeling if we click Save As, you can...
That'll work too.
Yeah, and it saves it as a graphic file that you can then open up in Paint if you have it. So that's perfect. Thank you, Stephanie, for that. That's great. Awesome. Okay, so that's again, Stephanie says in the toolbar that shows up beside the whiteboard, click on the three dots and then click send to OneNote if you're using OneNote, or click Save As, and you can save it as a graphic file on your computer and then just open it up in a Paint program. Okay.
You can also, once you go to save it, it'll say Save As Type. You can change that to, oh, sorry, I thought you could change it as a JPEG.
Yeah, I thought so too. I went and looked, and it says PNG or an XPS.
Yeah, I really thought you could change it as a JPEG.
That's too bad.
But I think you can open your PNG in Word.
Yes, I think so too. Yeah, I don't know what an XPS file though is, but
I wonder if it's Excel.
I don't know. It could be, but Word or Paint will work fine with that as well. That's great. Hopefully it's nice and big too, not small. Thank you, Stephanie.
No problem.
Okay, with that, does anybody have any other questions that they would like to go over? Or are we good for tonight? That was great. The hour seemed to fly by. If anybody has a question, feel free to stay behind, but otherwise, I'd like to thank you all for coming out tonight and for asking your questions. And if you haven't finished that worksheet, it's up to you whether you want to do it or not. As I said, it's only for practice and you don't hand it in. But if you want me to go over something for you, just post in the Q&A in the welcome unit or send me an email and I'll be happy to go over it for you. And that's it for tonight. If you want to stay behind and ask some questions, please feel free to do so. But otherwise, good luck with the rest of your studies this week. And you can just click on the X in the top right of your corner to get out of session. And I'm going to post the recording once we're finished. I'll process it and I'll post it up to the news feed. So thanks for coming out, everyone. Have a good night. And I'm going to just give us another, if you haven't saved it as a file, save it now, because I am going to give us a new page here in a second, if it's going to let me. I don't think it's going to let me go down any further. Let's see. Nope. Okay, so I'll get rid of this. Whoop. So we have Ashley and Stephanie and Tracy left. Ladies, do you have any questions for me? Oh no, go ahead. Oh, you mean the quiz?
Basically, I'm just wondering, when I did the experiment for the lab,
Oh, yes.
I wasn't exactly expecting the salt to be in the form that it was in.
Oh, yeah.
To the point that I had to ask my husband if I actually did it right. Because it's not anything that I really had anticipated whatsoever.
Cool.
Like,
I love that. I love those
expected.
results.
Yeah, it was more like a WTF moment. Like, I really thought I screwed everything up.
As long as there's no fire, you did fine.
Oh,
So go
my
ahead,
gosh.
explain. What did you do?
Well, I boiled the salt.
Water.
I boiled water and I
Yes.
put the salt and the sand mixed together in it.
Yes.
Then once I took a coffee filter and I put the whole mixture in it. So obviously the water and salt that was diluted went into the bottom of the pot.
Yes.
And then I kept the sand in a coffee filter that I let basically air dry. Not that the form changed. But then once I basically evaporated the water to get the salt, it ended up being like a paste.
Oh, okay.
So
Cool.
then from there, I just took it from what was left in the pot and I put it on a clean coffee filter. And then I just let it bake in the oven to see if it was just not excess moisture that was left.
Oh, very good. Yeah, that's
And
great.
I expected the salt not to go back to its crystal form, but it's really like powder. Like, honest to God, it looks like cocaine. I'm not even kidding.
You don't have cocaine, it's still salt. Those are great. So what you have is that it just, the texture changed. So it's just a physical change, but not a chemical change. So you still have salt. It's just that it changed texture. Do you remember the name of a powdery texture? It has a special name, just like when you had the crystals, that's a crystalline form. When it changes to a powder, do you remember the name for that?
Oh, I wrote this down the other day.
It starts with an A.
Oh, man.
That's okay. I'll amorphous.
Oh, yes.
Yeah, amorphous. So
it's completely normal that the salt will do
that
this.
Is it? Yes.
Okay.
So what you want to do is you want to make sure that you, first of all, that you, when you do your procedure, that you make sure you list all those things that you did, including taking that salt paste and putting it in the oven and baking it in the oven, so that you cover that all the procedure that you did. That was fantastic. Okay. And then in terms of your data, you're going to have your data in a data table, which is going to be your salt before and your salt after.
Right.
The observation that the texture changed, that's going to be at the end of the data section. So you usually do your, you'll have a data table, and then any calculations that you did, you want to have that underneath. And then your observations, you're going to write in paragraph form underneath that. Now, if you only had one interesting observation, like it was just the texture change that you wanted to say, then that would just be one sentence. So don't feel that you have to have you have to write a lot in the observation, but a one sentence will do, or however many sentences you need, and you can just say, without using personal pronouns, it was observed that there was a change in the salt's texture after it was baked in the oven, and then just state the change.
Okay, so when I do that graph, let's say, do you recommend putting salt in one graph and then sand in the other, or combining both so that you can see the like, I know there's in the book, there's a table that states, I think it's for like the gases, the gas, the solid, and then the liquid, where it becomes soluble or insoluble. Do you like recommend a table like that?
So yeah, I would say a table for sure. Graphs are always optional unless it was asked for in the lab. So you don't need a graph for this one.
No, I knew that one.
Oh, good. So what I would have for my data table is I would have the amount of salt, the amount of sand, and the amount of water that was used, so that was measured before the experiment. And then I would have in the same table, in another column, title the column amount after, and then you can do a side-by-side comparison for how much sand you had in the beginning and how much sand you recovered, how much salt you had in the beginning, how much salt you recovered. I guess you don't really need water there. Water would have been something that you would have put in the in the materials list, like how much water you used, and because you boiled it off, you wouldn't have an after amount, or it would be hard to kind of quantify that in the salt paste that you got. So I wouldn't expect that.
Okay, so like what I did was, for the water, I started off with 15 mils.
Yes.
And then I kept adding some as needed. So I ended up with like 60, just to make sure that the whole, like, everything was covered.
Yes, yeah.
So in that sense, would I state that I started with 15 and ended up with 60, or do I just state that I had 60 right off the bat?
I think I would just put 60 off the bat.
Okay.
Yeah. And then how did you measure before and after? Did you use a scale, or did you use...
I started with a tablespoon and then a teaspoon, and then I filled those back up using the exact same thing.
Yes.
So obviously, like with the salt, the form, when I started off with the crystals, it was nice and even, and then because it became in powder form, it's actually overflowing a bit.
Yeah.
So it's changed.
Yeah, and that's because of, now we know that most people are doing this in a kitchen and they won't have scales. If you had a scale, then it wouldn't matter what what texture or volume, because you'd be measuring the mass and you wouldn't have to worry about that. But because you're using tablespoons and teaspoons, and a tablespoon is 15 mils and a teaspoon's 5 mils, what I would suggest is that you pack it a little bit just to try and help. But in the end, it's not going to be something that there's still going to be room for error, because mass is actually a better way to measure amount than volume. So,
right.
So that's a great thing to mention in your sources of error in the discussion conclusion part of your lab. You just want to mention that would come up. But yeah, you sound like you've covered all of your bases. It sounds great.
Perfect.
Yeah, great. So do you feel good about that now?
Oh, I kind of do. It's just now trying to put it into an actual lab. I've been out of school like 5 years, and I'm a massage therapist, so I've spent the last 5 years basically writing in abbreviations, trying to find my words. It's like it's awful.
Well, I'm gonna put this out there, is that if you want me to have a look at your lab before Friday, in whatever form it is, I'm happy to do that. Just send me an email, attach it, and I can have a quick look. And that's for anybody in the course if you want to do that. I'm happy to do that, and then I can give you a few pointers before you write your final copy.
Perfect.
Great.
Thank you so much.
You're welcome. And Tracy, did I hear you had a question?
Yes.
Yes.
I'm just wondering, it says in the lab about photos. I'm just wondering, do you want us to be documenting every step, or...
No. If you
what does that look like?
Yeah, if you want to just take a picture, one or two pictures, what you can do is do a picture of just all of your materials ready to go before, and then the result of what you got. It might be a picture of just the sand and salt after, or it might be, for instance, if you used Stephanie's method of boiling off the water and having just the salt in the pot, then that would be great as well. But two pictures at the most. Yeah.
Okay, perfect.
Great.
All right, thanks so much. I think that's it from me.
Okay, great, Tracy. Thanks for coming out.
Thank you.
You're welcome.
Yeah, take care.
Bye now.
Okay, bye.
Okay, well, if any more questions, Stephanie, Ashley? I'm not sure. Ashley might be stepping.
No, that's it for me.
You're good? Okay, great,
Yep.
Stephanie. And Ashley's typing you are there. That's great.
Thank you again.
Oh, you're welcome. And just if you feel like doing that, you can just email me, and I'm happy if you have time to do that. Even Thursday night, I can have a look Friday morning, and it's not due until Friday midnight, so no worries that way.
Okay.
And Ashley's all good as well. No problem. Well, with that, I think I will say good night, and I'm going to shut off the recording. And thanks for coming out.